So what we're doing this week, I had this Piazza post. Hopefully you all remember this. Hopefully you all voted and put what you want on there. I'm going to go through this post. I have a few things that I want to do as well, but I'll go through this post and what y'all suggested, that's what we'll do. Of course, final exam review, example questions. I'll probably save this for Wednesday or Friday. I'll go over it real quick. I did it real quick a few times, but I'll do it real quick again right now. I'll give you several app descriptions. Like maybe one will be a bank, right? Banking software that takes deposits, withdrawals, has checking and savings account, etc. And I'm going to ask you for each of the 4 learning objectives, explain how you would use what you learned in that learning objective to be able to build that app. So for example, for learning objective 1, I'm going to ask you about testing. How are you going to test this thing? Like what methods are you going to write and how are you going to test those methods? Give me some test cases, etc. For learning objective 2, OOP, where are you going to use some polymorphism? Where are you going to use some inheritance? And how are you going to use that? So for the bank example, well, I got 2 different account types. Probably going to use some polymorphism there. Probably have some base class, which is account, and then checking account and savings account both extend account and shares all the functionality from the account class, and just has whatever specific to them implemented in those classes. For learning objective 3, functional programming, either where are you going to use some first order functions or where are you going to use concurrency? What should be concurrent in this app? And then learning objective 4, tell me where you could use either a graph or a tree. And admittedly for LO4, it might be a little bit contrived where you're going to use a graph and a tree, but as long as you can explain some type of data in there that could fit into a graph or a tree structure, that would suffice for that. No linked list, because you can use linked list for like everything. I'll have a list of bank accounts. Okay, but that doesn't show me you learned anything from that learning objective. And I'm not going to ask you about like the structure. We're already asking about the structure of a linked list, a tree, etc. in the interviews. So I'm not going to hit you with that again. But I want to know, can you apply, obviously application objectives, can you apply what you learned to solve a real world problem? That's what I'm getting at for this. So can you speak, not even necessarily at a technical level, but can you use these things that you've learned in this class all semester to actually go out there in the real world and do something with it? That's really what all the applications are about. Some of them do just turn in, most of them are just programming examples, but they're always programming to be able to solve some end problem. I read this a few times, I still don't understand it. Possibly a class-wide poll to review certain topics. Trying to distinguish what's the difference between this Piazza post and what you're suggesting. This Piazza post is the class-wide poll to figure out what we're doing. So I'm not quite sure if there's some nuanced point there that I'm missing, let me know, but I think that's what we're doing right here. Like if you have a certain topic you want to review, just post it, just like the last one here, just like the last one. If you want specific topics, just put them in this post. We don't need a class-wide poll for that other than this. Thread for AO suggestions. I'm not doing the 4 prep labs thing. Every lecture is an AO, no. Would it be all right if the AOs from previous LOs get reopened during review week? Lots of AOs were interested in, but we couldn't find time to do them. So these two, all the AO stuff goes together. I'm going to knock this out right here. If you haven't seen this yet, I literally just posted it, so you might not have. But I do have my course evaluation bribe out there, or incentive, if we want to be a little politically correct about it. So my incentive here, so for those of you who don't know, the course evaluations, it's your chance to give feedback about the course. This is very valuable feedback for all of your courses. My colleagues and I do take this very seriously. We love getting, it's difficult to get feedback about our courses. Like I could stand here and ask you, how do you like the course? What don't you like about it? What can I improve? It's really hard to get information out of you. So these course evals are like the one time where we really get this in the midterm evals. That's the 2 times where we really get feedback from you, where you're sitting down and actually typing up feedback for us. So it's a really nice thing. that UV sets up. I mean, every university does this. But it's fully anonymous, and I don't get to see what you say until after final grades are due. So it has some protections against you. You can be open and honest as you want to be. Let me know if there was things you really didn't like. Let me know. That's valuable feedback for me because I know what to fix. If you liked everything, that's cool too. I like hearing that. But even if you like things, if there's anything that can be improved, that's really what I want to know. Like, what can I do to make your experience a little bit better besides the obvious, like just make the homeworks easier, because that's what everybody would suggest. And even then, if the homeworks can be easier in a way that still has you learning the material and getting practice with the material, I'm fine with that too. If there's something about the homework where you were just spending hours and hours and hours on it without learning, or that time spent wasn't a reflection of something that you misunderstood about the material, it was just like some IntelliJ setup thing. I mean, let me know about that too. I want to know about all those things. I feel like we have things running fairly smooth on that front, where a lot of what you're doing is related to the course, but there might be a lot of things missing that people just haven't told me about, nobody's told me about yet, that I can restructure the homeworks, et cetera, and fix those things. If you don't believe me on that, things were messy the first few semesters of this course. The first few semesters that we introduced Scala has a lot of intricacies and stuff. We got rid of most of that by right at the beginning of the semester. We say use this version of Java, use this version of Scala, and that resolves a lot of headaches that occurred the first few semesters, or at least the first semester. It didn't take me long to find that one out. But anyway, that feedback's invaluable. So here's my bribe. The only piece of information, so I don't get to see who filled it out or what you said. So the reason I say that is because I can't base my incentive off of, did you fill out the course eval? I can't do that. I have to go class-wide. The only information I get is the response rate. So that's the only thing I can incentivize. If the response rate gets up to 60%, I'm going to open the application objectives for genetic algorithm, 70% point of sale, 80% pale blue dot. So if we get up to 80%, even if we get up to 70% and you don't have a single application objective yet, you could still skip the final exam. So I think this is a pretty strong incentive. I'll find out as I watch the response rate. But I'll reopen the old application objectives depending on the response rate. These will, I better make sure it's this. And I'll open them to the last day of class. So as soon as we hit, I'll be watching the response rate. As soon as we hit a threshold, I'll unlock that homework. I'll go into IntelliJ. I'll go into AutoLab and move the deadlines back, and I'll re-upload the grader to reopen the application objective, and I'll set that deadline to December 10th at 11:59 p.m. So there's the incentives. I think I can do this carefully and get the percentages up. Oh, I've got too much stuff open. And we're at 17%. It jumped up pretty quick right after I made that Piazza post. So that should climb up pretty quick. Usually right when the incentives are announced, that number will shoot up. You can tell I haven't announced any incentives for 442 or 312 yet, so they're still pretty low. And in just like half an hour, this shot up pretty high. So get those evals in, tell your friends, get their evals in, and we can hit these incentives. I can get something I want, you can get something you want. It's a nice win-win. I get feedback, you get application objectives that you can still do, and still skip that final exam if that's your goal. I'm purposely not pinning this post, by the way, if you're wondering about that. Purposely not pinning that because I don't want people who don't show up to lecture, I don't want it to be super accessible to them so they can just type some crap in there that nobody wants and then waste lecture time for people who actually do show up. Okay. does the final exam have an interview? I want the final exam to have an interview. It's just not practical. As soon as labs are over, we don't have a convenient way to do interviews. So that's why the final exam has a different structure. Info at all about AO2. I'm stuck at firing. I'm not going to really talk about AO2 on enemy AI. It's all about trees. I'll stick with the hint I've given before that you really have to understand the structure of all the code that's given. The code that's in the AO2 method, make sure you're studying that and really understanding how that works first. Granted, that's just random. It doesn't read the state of the game at all. So in your AO2, you're going to have to actually read that game state, parse that game state, find closest players, things like that, make decisions based on the distance of the closest player, et cetera. How many AOs do you need to skip to do? Yeah, Nicholas says, you there? Only 6 AOs to get an A in the class. That used to be 8. It used to be 8, and there was only 1 AO per homework, and there was a 5th thing. There was project contribution where you contributed to a GitHub project, and the final exam was 1 AO. You had to get everything to get an A before. I've lightened up on that significantly, so I hope you appreciate that. My attitude, by the way, for the structure of the course is there are things that I need you to know before you can go on to 220, 250. If you don't know these things, which I sat down for a long time, I thought about, they are exactly the learning objectives. These are the things that I need you to know before you go on. If you don't know all of those things, there's at least some part of 220 or 250 that's going to really kick your butt, that you're probably going to fail. Either fail or you have to work double time next semester to be able to pass those courses, to be able to move on, to be able to keep going. Once you know these, I don't have a better way to word this, so I'll just say it. I don't really care that much about your grade. If you're passing or failing, that's what I really care about. Are you continuing on? Are you ready for the next semester or not? I'm kind of a gatekeeper in that sense, where there's certain thing that I need to hold you accountable for to be able to learn. That's the learning objectives. Once you get all 4 learning objectives, I'm pretty laxed on you getting an A. Like, you might as well get an A if you're going to get all these learning objectives, if you're going to go through all the interviews, all the projects, all the lecture objectives, or lecture tasks, all the quizzes. You're going to do all that. Like, I'm cool with you getting an A. Like, I don't want to hold that back from you, because me giving you a C instead of an A is just seems kind of cruel, I think, to be honest. So I don't care that much after you pass. So I'm going to make the threshold to jump up to an A not that difficult, especially opening up the AOs. I always planned on doing something with the application objectives for the eval bribes. I didn't know exactly what I was going to do yet this semester. I do something a little different each time. But open them up so all 8 application objectives can be available at the end of the semester. I mean, most of you should be getting an A without even needing the final exam, assuming we get to 80% on the evals. I got sidetracked. I forgot why I was even talking about that. Oh, yeah, because somebody asked how many AOs you can skip. All right, talked about that, and this is the one I want to spend today on. If anybody wants something different, get in here and vote, because maybe I won't spend too much time on it because it's only 2 students, but 2 probably translates into at least 20, I would assume. A lot of people just haven't gone on to this post. But yeah, linked list, trees, and graphs. I'm just going to go through some examples in the examples repo, and then we'll take it from there. If there's not much else, we can talk about this some more. I assume with the incentives that this is less important, though, the final exam review. But I'll still spend more time on that as we get closer to the final exam. But if there's nothing else that y'all want to talk about, this is the only content suggestion. Either get something on there or let me just leave it at that for now. All right, so let's talk about this stuff. Let's do some CSE 116. Start with linked lists. Linked list example. And I'm not going to go through the debugger. I don't want to spend a ton of time going through all this, but I will verbalize. Let's walk through this code and verbalize what's going on with this code. So this should be really good quiz practice, just looking at the code and figuring out what's happening with this code. So we're going to create a linked list. A linked list is made out of nodes. Each node stores the value that it's holding and also a reference to the next node in the linked list. So I'm going to create a brand new linked list node with the value 1 and a next of null, meaning that there is no next node. This is the last node in this linked list. I'm going to create another node with the value 3 with a reference, with next being a reference to my list, which is, at this point in time, contains this linked list node of 1. So after this line executes, my linked list is 3, which refers to 1, which refers to null. At this point, my linked list is 1, null. And then when I get to this one, I'm going to create another new linked list node with the value 5, which refers to my list. Since I reassigned my list to this node, my list is now referring to this node that I created that stores 3. So I have 5 with a next that refers to this node, which has a 3, which refers to this node, which has a 1, which refers to null. So that's the end of the list. So now after this code executes, I have a list. My list stores a list, the head of a list anyway, that refers to 5, then 3, then 1. Don't make the mistake. It's a fairly, not super common, but one of the mistakes, really one of the only mistakes you can make on the linked list question, is having this list reversed. Don't be telling me on the quiz that this is a list that's 1, 3, 5. It's not. Pay attention to the way that the list is being constructed. This is 5, 3, 1 because it's being constructed in the reverse order. Don't just glance at this and go, oh, 1, 3, 5. A decent number of students do that. Make sure you're really paying attention to the structure of the linked list. Show me that you understand how these references work, because I'm purposely going to build it backwards to make sure you're watching for that, making sure you're paying attention to it. And we have some questions about it. My list, which is currently referring to this node, .next, which is this node. I almost lost my train of thought there. .value is going to be 1. So knowing how to follow those references to be able to get to the next one, to get to the values that we're looking for. I'm going to skip a little bit of this, and I want to get to a function. Let's go right to the last one so we can get to trees and graphs. So let's go right to this one. I'm going to use mylist.map and give it a function that takes an int and returns that int squared. So this is a function. I should put my type parameter here. This is a function from int to int. And IntelliJ is going to say, you don't need those parentheses there. So I have a function from int to int. I'm going to call map with this function on my list, which we did prepend a few more values, 10, 11, and 12, which prepend does the same thing that we did when we were prepending the old, I guess the old-fashioned way, this way. So we have a list that's 12, 11, 10, 5, 3, 1. And we're going to call map with this function. Map with this function. So map, let's get this expanded. So map is going to take that function, and it's going to be called on the head node of this linked list. And it's going to call the function on the value of that list. So on the head of the list, we're going to have 12. We're going to square that. New value is going to be 144. And then we're going to check. We're going to hit our recursion and say, is this the base case? Our base case is this is the last node in the list. If next is null, this is the last node of the list. And we're just going to return a new linked list node with that new value and next of null. So, or we can say this as the input is a list of size 1. If it's a list with just one element, we're going to return that same element with that new value, which is the value that it was, but with this function called, or with this function applied to it, the output of that function on that value. And a reminder, I should review what map is. So map is creating a whole new linked list with all the same elements, but those elements, I always struggle on the way to word this one. It's all those elements. I usually say with the function applied to it. That's the wording I use on the homeworks whenever we have functional programming in the homeworks. But it's those elements, I'll try to word it a different way here. It's all the elements of one list. Call the function on all those elements, and then whatever the outputs of that function are, return a new list with all those values. So if we have a list of just one element, we're going to call the function on its value, get the return value, and return a new linked list node with that value, which refers to null. If this is not the last node, if this is not a list of length 1, we're going to do roughly the same thing. We're going to create a new linked list node with that new value, with the function applied, the output of the function on the current value. But then we're going to recursively call, and this is where all the magic happens, we're going to recursively call map with this function on the next node. So we know next is not null, so it has to be some linked list node. So we're going to take that linked list node, call map on it, and we're going to assume that that returns a new linked list of every node after this node, but with the outputs of that function. So we're going to make the recursive call on the next node and just assume that that returns that whole list that I need. And I'm going to have this node refer to that next node that's returned by the map, the recursive call of the map function. If that does return that whole list, then I just want that to be my next, and that's it. And at some point, this is going to hit the base case and just return that last node. If it's the second to last node, this is going to return and be the next here. And then once the second to last, the third to last node, it'll be the one before, and et cetera, et cetera. So we're basically taking this let's see if I can do this. Oh, what am I trying to do? I think that's going to be more confusing. I was going to try to unroll the recursion and show you like what it would look like without recursion if it was fixed size. I think that's going to be more confusing. I'm confusing myself just trying to do it, so let's not do that. And that's an example of an algorithm that we can call on a linked list. So like for your quiz, you can expect something fairly similar. We're going to construct a linked list. We're going to make a linked list, and then do something with it. There will be some algorithm that we're going to throw at this linked list to make sure that you understand the structure, understand how this .next works, and how a recursive method works on a linked list. How are we going to be able to traverse the list to be able to get something done? And we talked about how to find an element, how to map a list here. We did find a few different ways. How do we find an element? A lot of it's going to have some recursive method where the base case is checking if next is null. If next is null, we're at the end of the list, or we have a linked list of length 1. Else, we have to make a recursive call. Trees. For trees, we set things up a little bit different, just the way that the way it kind of lends itself. With a binary tree, well, let me back up and talk about linked list node. With linked list node, we had a node with a value and a next, and then we had a lot of methods in the node class itself. So with the tree, we set it up a little bit different, just a different approach, a different strategy. With a binary tree, we don't have anything in the binary tree class itself. We just have the value left and right, and that's it. That's the entire class. We never added anything else to the binary tree class. And then we had our algorithms in a separate place, in an object in this case. And then we had these 3 traversals where we're navigating around this tree. Why can't I see anything? Oh, because it's right in this. So when we wanted to create a tree, we had to do things manually, like we did with those first 3 elements, the 5, 3, 1. We had to do all of it that way because we don't have that prepend method. We don't have any method like that for a binary tree. We talked about inserting into a binary search tree, but again, that was outside of the binary tree node class. So for this, we're going to create a binary tree node, value 5. So our entire tree is just, do I want to commit to this? Our entire tree is just 5. And we're going to say root.left. So this node that has the value 5, its left, which we set to null, override that with a new binary node that stores 2. So now our binary tree is going to be 5. Oh boy. Let me do it underneath. It's going to be 5. Then over to the left is going to be 2. I'm not going to keep doing that for every one of them. But we have 5 at the root, and then root.left is going to be a node that stores 2. And then wherever I don't have any of the left or right children, those are all null. Then we're going to say root.right is a node with 8 in null, null. So we're going to be, let me cut and paste. I'm not going to draw another one after this one. It's going to get tedious. This is why I don't have you, I probably haven't mentioned that, but I'm not going to have you, we're not going to say, here's the code for a tree. What's the tree look like? We're not going to ask you that on the quiz because I understand it's tedious, especially in a Google form. How the hell are you even going to do that? So we're not going to ask you to do that. It's going to be, here's the code that makes a tree. We're going to throw a traversal at it. I'm going to give away the whole question here. We're going to throw a traversal at it and ask you in which order are the values printed to the screen for that specific traversal. So then it's just one list of elements. And of course, explain the execution of it as it goes through. So we have 5 at the root. The root's left is 2. The root's right is 8. And then we're going to keep going. The root's left is -3. The root's right is 4. The root's left is 7. The root's right is 14. So we're building that whole tree by manually setting the child nodes of each node as we go through line by line. Then we throw the traversals in there. In order traversal is going to print these, is going to make the recursive calls, the left recursive call before, the right recursive call after, and right in the middle, we're going to call this function. Call this function on the node's value. So we're going to go recursively left, call the function, recursively right, and then end that frame of the recursion. So an in-order traversal if this were our whole tree, in-order traversal, we're going to go left. Left is null, print 2, right, and then return. Print 5, go left, null 8, null, return, return. So in-order traversal is 2, 5, 8. If this were our whole tree. If we want to do a pre-order traversal, that means we make the recursive call, or we call the function before each of the recursive calls. So we're going to call the function 5, 2, recursive call, return, recursive call, 8, recursive call, return. So we get 5, 2, 8 in a pre-order traversal. And then post-order traversal, make the recursive calls and then call the function. Post-order, recursive call, null, null, print 2. Go back, recursive call, 8, 5. So in that case, we would get 2, 8, 5. So we get 3 different orders based on the traversal. So if I give you code to build a tree, and I throw one of these 3 traversals at you, if you can get all the values printed in the right order, I can infer that you understand the structure of the tree and you understand the order of the traversal. Or maybe you just got lucky, and you know what, that's okay, I guess. But we can infer all that without having you draw these trees out. If it was a pen and paper exam or quiz, I would have you drawing those trees for sure. You can bet that. But on a Google form, it's just a pain in the ass, so let's not do that. And then binary search tree, I won't spend much time on right now. Binary search tree is an application of binary trees. So I want you to understand that a binary tree has these nodes, has left and right children and their values. That's what I really want you to get out of 116. Binary search tree was an application of that. So maybe for your quiz you don't see these. But for your interview, if your interviewee says, so where would we ever use a tree? Like what can you do with a tree? You do binary search trees and keep elements in sorted order in a tree structure, in a binary tree structure, would be an awesome answer. And then you can explain like what a binary search tree is at that level. You won't have to read the code for it though. But a binary search tree is made for exactly that, to keep elements in a tree structure in sorted order. And they have a lot of really nice properties that you'll talk about in 250 at length. For our purposes, it keeps the order of the elements. Everything to the left subtree is less than, everything to the right subtree is, I did that backwards, is greater than. And as long as that condition is satisfied, you're going to have really nice properties of this binary search tree, not the least of which is an in-order traversal, traverses the elements in sorted order, which is a really nice property to have. Which takes us to graphs. Did I miss anything in here? Do you have to trace through the stack and heap for linked lists in the quiz? You should be. I have to look at. I have to talk to the TAs about that one. You should be able to. I'll say that much. You should be able to show the stack and heap at this point. Like, there's no reason for you not to be able to do that. We hit you with that on all 3 learning objectives by now. We talked about stack and heap. If you're concerned about that, then I'm concerned, and maybe we should put it on the quiz. But my attitude is, we already hit you with that 3 times. We talked about, we had you do stack in LO1, heap in LO2, and then stack and heap in LO3. Do we have to hit you again? Do you not get it yet? So that's kind of my approach there, that we might not explicitly ask for that. We might just ask you to trace through the thing. But if that question's coming up, is that something y'all need more practice with? If you do, maybe we should put it on there. That question's concerning. Because by this point, you should be like, oh yeah, stack and heap, I got that. Who's still struggling with stack and heap? If you're still struggling with stack and heap, oh boy, 220 is going to be rough. 220 is going to take stack and heap and run with it. And you have to manage your own heap space in your programs, in the programs you write. You have to manage your own heap space. If you don't understand stack and heap by now in references, that question does have me concerned. Because that should be second nature. Understanding references and how things are stored in the heap, that should all be second nature to you by now. All right, so for a graph, we did things, again, a little bit different. There's a reason we talk about 3 different data structures, because they're all a little bit different. So with a graph, we didn't have a convenient way to store like nodes and references to other nodes and things like that. So we took a completely different approach. We stored all the nodes in, we had a new class. We stored all the nodes in a data structure. And then all of the links between nodes, any edges between 2 nodes, we stored in another data structure called an adjacency list. The nodes, the reason we have this map of nodes is strictly for convenience. We want to be able to write algorithms for these nodes, and we want to use certain features like equality. Is this node equal to this node? That's easiest to do just by giving them all an integer ID and then checking if they're equal based on the IDs. Now we could do that with any value a, but we'd have to override the equals method to make sure that it makes sense, and that gets tricky. So we're going to assign them all int IDs and then work with the IDs. So this map here is just remembering which ID correlates to which value in this map. What does this node with this ID represent is what this map is storing. Then the adjacency list, for each node ID, which node IDs is it connected to? So give me a list of all the neighbors of this node, which is every node that's connected to that node via an edge. So whenever we add a node, we're going to throw in our nodes map and initialize the adjacency list to an empty list for that node. Then every time we add an edge between 2 nodes, we're going to update our adjacency list for both nodes and prepend the other node to its adjacency list to be able to get that node those nodes in each other's adjacency lists. And the one big algorithm that we had was breadth first search, where we started at some particular start ID given a graph. We're going to mark the start ID as explored and add it to a queue, which is to explore. This probably should be like to explore neighbors of, something like that. But a queue, which is the nodes for which we're going to explore all the neighbors of that node. As long as there's something that we still have to explore, we're going to grab the node at the front of the queue, and for each of its neighbors, according to that adjacency list, we're going to visit that node. We're going to check, is this neighbor already explored? If it's already explored, skip it. Don't do anything at all. But if we haven't ever seen this node before in this run of BFS, then we're going to enqueue it and mark it as explored. So this is going to let us visit every connected node in this graph connected to the starting node and make sure that we only visit each node exactly once. We're not going to revisit a node ever. And then, of course, for your homework, you're expanding this BFS to be able to get properties out of these nodes. We want to ultimately find paths, the shortest path or a shortest path from the start node to some other node in the graph, which for our AI purposes are going to be the start node is the node of that AI player, and the end node, the path that we're finding, is the closest player to that AI. We want to find that path to the closest player. That's our ultimate goal with this, for the homework, the ultimate application of this. Which, and WebSockets and actors. You really packed a lot in that one, that one comment, Anonymous Adam. I'm not going to go over WebSockets and actors. I kind of will. I'll talk about them a little bit on Wednesday, my plan is, unless there are more posts on this Piazza post, more comments. Does anybody have questions? I don't know how useful anything I'm doing here is. I know 2 people like that. 2 people wanted to see it, but what's going on out there? Especially for review week, I need input from y'all, or else I'm just going to do my own thing once I'm done with what's suggested. Which I have covered everything that's suggested. I'll spend a little more time on final exam. Example questions doesn't make sense, so whoever posted this probably, oh, no, it's Cole. Cole knows what's up. I was going to say he probably doesn't know what's up, but example questions, yeah, Cole knows what's up. But the example questions, maybe that's, you know what, maybe that's fair. The example apps is what I would say. Which my bank app is my common example I'll give in lecture. Anything else? Anything? So let me know, use this post, let me know. I mean, this is the only thing I can really go in depth more of. The one thing that I want to cover is how to deploy your app, how to get it. I'll use the Towers game as an example. I'll go through that a little more in depth, and I'll show exactly how I got that deployed on the internet. That's my plan. Other than that, like, we got 5 more of these lectures, so if you want to see things, let me know. Or if your suggestion is to just skip some of these lectures, you know, if you'd rather just do something else with this time, let me know that too. If one of these suggestions is, you know what, we don't have to come here next week, you know, I'd honor that as well. So if you don't want to just sit here and hear me make up whatever, I'm okay with that. We can all recover this time. But if you do want to see something, let me know what you want to see. Sound good? Sound fair? Okay. All right. Have a good one. I'll see everyone Wednesday.